Welcome to our channel ClassFly community. So today we will be seeing the construction of the DC generator in a detailed manner. So let's begin with today's lecture. See, the first is a stator magnets. Stator magnets, stator is for stationary magnets. Okay, these are all permanent magnets. Here I have drawn a south pole magnet, a north pole magnet, right? These are basically electromagnets. So these are what? These are electromagnets with an arrangement. That means they are in such an arrangement that both are of the opposite polarity. See, I have written in simple words that these are basically electromagnets with an arrangement so that the poles have the opposite polarity to each other. Okay. This magnet thus produce magnetic field which in electromagnetic induction changes the magnetic flux. Now the second part is our armature. I have drawn a simple drawing here like this armature looks. Okay, it is a system of conductors or coils. Armature is what? Armature has windings, looping of windings of coils. So it is said to be a system of conductors or a system of coils which is free to rotate on the supported bearings. There are bearings whenever we do any rotation, we need bearings so that it continue rotates. Okay, that's what it is said, that they are supported with bearings and it is free to rotate and its work is to rotate. Okay, armature has various parts. Here we have been divided the armature in two parts. One is the armature windings, that is this brown part is the armature winding and the white part is the armature core. Okay, see, the armature core, it is made up of high permeability thin silicon contained steel lamination. This armature core is made up of thin silicon with steel lamination, with having content of steel lamination, and it has slots to carry armature windings. What does it have? It have the place for the coils to wind or to loop. Okay, now see the armature windings. What does it is basically? See, it is basically made of copper wire. The armature windings is made up of copper wire and is wound around the armature core, because the armature core has the position for the windings of the coils. So these coils are being wounded in this armature core. Now we will directly move on to our split rings or commutators. Split rings are also known as commutators. Okay, see, it is a cylindrical in shape and is made up of copper. Like this it looks, and it is made up of copper. Okay, and split rings, when you see in diagrams, sometimes it is like D-shaped like this. Okay, now see, its function are that it collects the current from the armature conductors. That means it collects the current from the windings of the coils of the armature, and it converts the AC of the armature. That means it converts the alternating current of the armature into unidirectional current in the external circuit with the help of the brushes. Its main function is that it doesn't change the direction. That means it is unidirectional, that it doesn't reverse the positions or reverse the current. Okay, if my in the 0 degree rotation, if my when the when this plate when the armature starts moving, if it is denoted with AB and it connected with CD, A is connected with CD and B is connected with AP, when it changes to 180 degree direction, at that position also, if AB changes its position, then the B split ring will also change its position. That means B and A will swap the position between the split rings and they will connect it to whatever it was connected when it was start moving. Okay, that means the split ring or the commutators doesn't reverse the current. Now see, split rings are attached with the brushes. They are usually made up of carbon or graphite. Okay. okay, carbon or graphite, and its main function is to collect the current from the moving commutator. The split ring which is moving, with the help of the armature, it will collect the current from that commutator or the split ring. Now see, the fifth part is a shaft. Shaft, it is a rotating part. It rotates, okay, and the final output is obtained in the form of the mechanical energy from the shaft. From the shaft we will obtain our output in the form of the mechanical energy, and the armature is mounted over, that means it is placed above the shaft. Okay, now we will see this all the parts in a full DC generator, how it looks. See, like this the DC generator will look when all the parts get connected. These are our magnets, okay, and this brown and the white part is the armature. This yellow part is a commutator, and the black, that is the which are formed with the graphite or the carbon, is the brushes, and the shaft, which is the rotating part, and as I told, the armature is mounted over it. See, the armature is over the shaft. So like this our DC generator will look when all the 5 parts get connected with each other. And I hope you all understood the construction of the DC generator. Till then, be happy and have a great day.
Now is the code time. Life is not a problem to be solved, but a reality to be experienced. I hope all of you understood today's lecture, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.